Hello everyone, good evening everyone. This is Tamil Rasan from Facebook. I welcome everyone for this particular session. Before the start, I'll have a quick check regarding the audio issues. Am I audible, guys? Some response, please. Hope I'm audible. Yeah, thanks guys, thanks for the response. So in this particular session, we are going to discuss about queue data structure. Last session we were discussing about stack data structure, but here we'll discuss about queue data structure. Queue is also a linear data structure which we have. In this particular session, we'll talk about queue. Just a recap about the last session. Last session we were discussing about stack data structure which follows LIFO order, last in first out. But queue will be slight different from stack data structure. Okay, where the elements in the queue are inserted from the rear and deleted from the front, where the element will be inserted at the back side of the queue and deleted from the front. So here the insertion and deletion both happens at the different place. When I go for stack data structure, insertion and deletion both happens at the same end. I can say the stack looks like this, where we had only one opening, where insertion will be happening at one end and deletion is also happened at the same end. But when I go for the queue data structure, let's take where insertion and deletion both happens at a different place. Okay, so that is what the first point is mentioned about. Element is inserted from rear end in the sense back end, where deleted from the front end. So here insertion and deletion both happens at the different end, both are not happening at the same end. So this follows the order called FIFO. Front points to the beginning and the rear points to the end. So queue follows the order of FIFO, first in, first out. So the element which has been inserted first into the queue will be deleted first. So when I go for stack, it is LIFO, L-I-F-O. So remember these things, guys. It can be asked in MCQs as well. And this is the most important concept in stack and queue. Stack follows LIFO order, whereas queue follows FIFO order, first in, first out. This is what called as queue. And one end is always used for insertion, that is called as Enqueue. In stack we use the term called push function for insertion. Okay, I'll just differentiate stack and queue so that easily you can understand. Okay, stack we used a term called push, but in queue we'll be using the term called Enqueue. Instead of insertion or push function, we used to call as Enqueue. Similarly, for deletion we had one term called which is called pop. I made a mistake. It should be Enqueue here. Yeah. And for stack, for deletion we have used a term called pop function. So here we used a function called Dequeue. Okay, which is called as Dequeue, where insertion and deletion are happened at the different end in queue, happened at the same end in stack. Here also we have overflow and underflow. So when do we call it as overflow and when do we call it as underflow? In the sense, when the queue is full, if you are trying to insert an element inside the queue, that is called as overflow. When the queue is full and when you are trying to insert an element, that is called as overflow condition. Similarly, when the queue is empty and if you are trying to delete the element from the queue, that is called as underflow condition. Similar like stack, we used to have these two terms similar like in queue as well. But for insertion and deletion, the terms are getting different. Here we used to say peak function. What is the use of peak function? To know the front element of the stack. Similarly in front, we have term called front element. From the front, we can say. So front states the front element of the queue. We can get to know what is the front element of the queue by using a function called front, by denoting a term called front. Hope this is clear for you about a queue. A real-time example. So one real-time example I can say is, let's take a one-way. So in one-way, like there are 5 cars going. So first car which is going will be reaching first. The last car which is coming will be reaching at the last. So this is one of the real-time examples of the queue, I can tell you. The basic and foremost example is nothing but standing in a queue. Standing in a queue is the most common real-time example for queue. Because if 5 people are standing in a line, the people who has been front will be given the first preference, second will be given next, third, fourth and fifth. This is how queue works and this is the real-time example. And you might ask, sir, can you give me some examples of application point of view? When we talk about application point of view, we can say printers. For example, I am giving 5 documents to print at a stretch. So the document which I have given first will be printed first. The document which I have given second will be printed second. Third will be printed third. Fourth will be printed fourth. Fifth will be printed first. So here the document which I have given third will not be printed first. So one application point of view, the example which I can give for queue is something but printers and calls. When you go for call centers and all, how come the calls have been received? For example, 2 people are trying for same person. The one who is trying first, his call will be given the first preference. So these are all the examples I can give for the concept called queue data. I'm going to insert my first element. I'm going to insert my first element in my queue. How can I insert my first element? Which is nothing but Enqueue. So Enqueue is nothing but insertion. So when I insert the first element of the queue, remember one thing, the value of back is incremented by 1 which becomes 0, and the value of front is also incremented by 1 which becomes 0. Okay, both the value of front and back will be incremented when you are inserting your first element. Guys, remember, I'll repeat again. When the queue is empty, this based on the people's convenience, you used to change and write the terms and conditions, but let's make it so simple. When the back value and front value is equal to -1, that is the initial part of the queue. That is the initial part of the queue which is empty. Okay. Next, when I am trying to insert my first element inside my queue, when I am trying to insert my first element inside my queue, so at that case, the value of back will be incremented by 1 as well as front will be incremented by 1, which is back and the front value are 0. Back value and the front value are 0. When the value of back and front are equal, we can say that the queue has exactly one element. When the value of back and front are equal, we can exactly say that the queue has exactly one element. Now let me try to insert one more element inside my queue. Now let me try to insert one more element inside my queue, which is nothing but the second element. When I try to insert my second element, what happens? When I insert my second element, the value of back will be incremented by 1. Listen, whenever you are inserting other elements inside the queue than the first element, the value of back will be getting incremented. The value of back will be getting incremented. Now, when I try to insert my one more element in my queue, let me insert my third element in my queue. So here what happens? I have inserted my third element in my queue. The value of back is incremented by 1, which becomes 2. So I have inserted my element inside my queue. So you are clear with Enqueue, I guess. Now let's move on to the concept called Dequeue. What is the meaning of Dequeue? Dequeue is nothing but deletion. So I am going to delete my element from the queue. So when I delete my element from the queue, which element will be deleted? We know that queue follows first in first out order. We know that queue follows first in first out order. The element will be deleted is nothing but 1. 1 will be deleted first from the queue. So the element 1 will be deleted. Now listen carefully. Whenever you are deleting an element from the queue, the front value will be getting incremented. So before deleting 1, the value of front is equal to 0. Now when I delete my first element of the queue, the front value is getting incremented by 1. Now let me try to delete one more element from the queue, which is the second element I am going to delete. So when I delete my second element, front value will be getting incremented by 1. This becomes 2. Now see that value of front and the back. The value of front and back both are equal. Now see the value of front and back both are equal. So when the value of front and back are equal, what can I say? It has exactly one element. Okay. Now let me try to delete that last element from the queue. So when I delete my last element of the queue, the value of front will be incremented. We know that. The value of front is 3. Now check the condition. When the value of back is less than front, or in other ways I can say, when the value of front is greater than back. You can write the condition in either ways. When the value of front is greater than back, or when the value of back is less than friend, if it satisfies any one of the condition, we can say the queue is empty. Okay, this is the concept about queue. Guys, we're able to understand this. I'll give a minute of time for you to recall. Then I'll just revise the concept of queue once again, so that it will be easy for you to understand. Now, can I have some response whether we're able to understand the concept of queue? Similarly, like last session, in this session also, I'll code and show you the concept of queue. Before that, were you able to understand this? If you have any questions or any doubts, kindly drop your questions in the chat box. I'll answer all your questions. Is it clear so far? Yeah, so I've got one response. Others? Yeah, I'm getting one or two responses. Yeah, Sandhya, I'll explain once again, no issues. Others? In case if you have doubt at any point, Sandhya, you can mention that particular place alone. I'll stress it and I'll explain to you. But again, I'll explain the concept of queue from the beginning. Yeah, sure, I'll explain. No issues, guys. Okay, so let's start from the first, where the queue is empty. Initially, I'm going to write the concept of queue. So when you're writing a program, remember, we don't have any elements inside my queue. So we have two terms, back and the front. Instead of the word back, you can say rear as well. In the front, we can say front itself. That's better. Okay. I'm going to give the value of back and the front as -1. So saying that this is the initial part of the queue where there are no elements inside my queue. I'm going to insert element inside the queue from now on. So when the value of back and front are equal to -1, which states that is the initial part of the queue where there are no elements. Now let me insert my first element inside my queue. Okay, where can I insert? The element can be inserted at the rear end, that is called as back end, and the element can be inserted at the front end, because queue follows a data structure called first in, first out. So element can be inserted at the last, that is the rear end. So when the element is inserted at the last, what happens in the sense, the value of back will be getting incremented. Because in the rear end only I'm going to insert elements, right? Whenever you're inserting the element in the queue, the back value will be getting incremented. Whenever you are deleting an element from the queue, front value will be getting incremented. Okay. Now I'm going to insert my first element. So when I insert my first element, what happens in the sense, the value of back will be getting incremented, because whenever we are inserting an element, the value of back has to be incremented. So remember this one condition alone. When you are inserting the first element alone, the value of front will be getting incremented. Okay, keep this in mind. Whenever I am inserting my first element alone, the value of front will be getting incremented. Now let's try to insert the remaining elements. And before this, we should know one condition. When the value of front and back are equal other than -1, I'll repeat, when the value of front and back both are equal other than -1, it states that the queue has exactly one element. Okay, when the value of front and back both are equal other than -1, which means that queue has exactly one element. Now let's try to insert another element inside my queue. I'm going to insert my element called 2. So when I insert my element called 2 inside my queue, the value of back will be getting incremented. Only for the first element, front value and back value both will be incremented by 1, which becomes 0. From -1 it becomes 0. From second element onwards, the back value, the rear or back, that particular back value alone will be getting incremented. So I've inserted, so back value becomes 1. Now let me try to insert one more element in my queue, which means 3 will be inserted. The back value will be getting incremented by 1, which becomes 2. Okay. Now I have done with my queue. So let's take the size of the queue as 3. So if you are trying to insert, like I want to know whether my queue is full or not, which is whether it is going to overflow or not. How come I can know whether it is going to overflow or not? We know the size of the queue. When the size of the queue, we know the size of the queue. Let's take size of the queue as 3. We know the size of the queue as 3. When the size of the queue is equal to back plus 1, we can say queue is full. Okay, guys, were you able to understand this? Other than this, we can give one more condition, that is nothing but size minus 1 equal to back. When size minus 1 is equal to back, we can say queue is full. After this, I cannot insert. So whenever you are inserting, just remember this condition alone. Whenever you are inserting, just remember this one condition alone. Okay. Now I have inserted all the elements inside my queue. Now I have inserted all the elements in my queue. Now let me try to delete an element from the queue. Okay. Where can I delete? Whenever we are deleting, the deletion can be done at the front end of the queue. The insertion can be done at the back end of the queue or rear end of the queue. Now let me delete the element from the queue, which is called as Dequeue. Okay, I have deleted my first element. So when you are deleting the first element, the front value will always be getting incremented. The front value, previously the value of front is equal to 0, right? Now the value of front becomes 1. When you are trying to delete the next element, and each and every time you can check the condition, which is whether the back value is less than front. Soumya, have asked a question, back less than front case you didn't understand. I'll just repeat, no, I'll explain you clearly. So when the value of back is less than front, if it satisfies this condition, which means queue is empty. So here the value of back is 2, front is 1. 2 less than 1? No, 2 is not less than 1. So queue is not empty. So the queue is not empty. So I can delete one more element called 2. So when I delete, front value will be incremented by 1, which becomes 2. Now check whether back is less than front. No, back is not less than front. Both are equal. So it doesn't satisfy the condition. But it satisfies one more condition saying that back and front are equal. So when back and front are equal, we can say that queue has exactly one element. Now let me try to delete one more element from the queue, which is the last element, 3. So when I delete the third element from the queue, what happens in the sense? Front value will be incremented by 1. Now check the condition, back less than front. Of course, 2 is less than 3. So when back value is less than the front value, which means that queue is empty. We can say that queue is empty. I cannot delete any elements further. This is called as underflow condition. What is meant by underflow condition? Whenever we are trying to delete an element from the queue, when there is no element, that is called as underflow condition. So this is called as underflow condition. That's all. This is the concept of queue. Soumya, is it clear for you the back less than front case, and others were able to understand the concept of queue? Shall we move on to the next part and the coding of queue? Can I have some response, please? Yeah. Assuming that you are clear with these concepts, I'll move on to the next concept, which is called as circular queue. What is the meaning of circular queue? Which is nothing but where the front part and the rear part both will be connected together. So when both front and the back, when both are connected, that is called as circular queue. So here it says that in circular queue, each node is connected to the next node. Obviously, one node will be connected to each other. Okay, but the last node's pointer is also connected to the first node address. The last node pointer is connected to the first node address. That is called as circular queue. Hence, the last node and the first node also gets connected, making a circular link overall. I'll just show you a picturized form. This is the first element, second element, third element, fourth, fifth, sixth, seventh, eighth. So this is my last element and this is my first element. So when both are getting connected, this is called as circular queue. We can say music player is also one example of circular queue, because after 8 songs, if I want to get connected to first song, I can come back to first song. I have an option. So I can come to the first song. That comes under the concept of circular queue as well. Okay. Next, one more queue we have, which is nothing but priority queue. What is meaning of priority queue? So I have 7 elements, but I need to give priority for the third element first. then I have to give the priority for the fifth element. Then I should come for the first element, second element, fourth element, sixth element, seventh element. So some priority I should give. For example, I can say, let's take the call center. So you are making a call, at the same time the country president is also making a call. Whom will be given the first preference? President, because he is a VIP. So for such cases, whenever you want to give some priority for something, there comes a concept called priority queue. When you want to give some precedence for some particular case. One more example in problem solving I can say is nothing but you want to insert elements inside the particular data structure concept. Let's take some certain data structure where the maximum element should always be in the beginning. You are giving such condition. There I can go for the concept of priority queue. When I go for the concept of priority queue, I am just saying that maximum element should be in the beginning. So whenever you are inserting elements in the queue, whenever you are inserting the maximum element, always it will be in the beginning. So there I am giving a priority for the maximum element. I am just giving an example alone, guys. I am just giving an example alone. So in a certain collection where I am going to give a priority only for the maximum element. So always the maximum element will be in the front. So this is the concept of priority queue. Priority queue makes data retrieval possible only through a predetermined priority number assigned to the data items. So for each and every data, we'll give a priority number as well. Okay, here in priority queue, we'll not just give the value alone. How come I can know the priority? To know the priority, we have to give the priority number as well. So while deletion is performed, in accordance to the priority number, the data item with highest priority is removed first. The data item with the highest priority will be removed first. So in accordance to the priority number, insertion is performed only in the order. So when deletion is performed in accordance to the priority number, insertion is performed only in the order. So whatever the order which you are giving, for that order only insertion will be happening. Chanakya, for priority queue it will not be in circular order. Circular queue is a different concept, priority queue is a different concept. Initially we were seeing a concept of queue, then we moved on to circular queue, then now we have moved to priority queue. Priority queue will be given the priority. If you want to give priority for certain things, you can give priority as well. Okay. Earlier we were discussing about circular queue. Is it clear, guys? Next, I'll move on to the one more concept, which is called Dequeue, which is called as double-ended queue, So what is the meaning of double-ended queue? It is nothing but where insertion and deletion both happens at the same end. Okay. Double-ended queue or Dequeue allows the insert deletion operations from both ends. Where in the normal queue, insertion will be happening at one end, deletion will be happening at the other end. That is what we have seen. But in double-ended queue, insertion deletion can happen at the both ends. Queues are also an important concept of data structure, and understanding their types is very necessary for working appropriately with them. So there are n numbers of queues, right? Initially we have seen normal queues, that is called a simple queue. Next one is nothing but circular queue. Next one we are talking about priority queue. Then we have moved on to double-ended queue. So when we go for double-ended queue, by this picture you can get to know. So insertion and deletion, both the ends. At both the ends, I can perform insertion as well as the deletion. This is called as double-ended queue. Yeah. So for priority queue, the priority number will be given based on the users. Because I want to give priority for certain things, right? So based on the priority it works. Any questions? One real-time example I can give for priority queue is nothing but hospital queue. Like for example, a guy is going for just a normal just checkup, and one more guy who met with an accident. So in these two scenarios, whom will be given the first priority? The person who has met with an accident. So for him, the first preference will be given. The priority will be given first. So that is the concept of priority queue. Is it clear, guys? Most probably in priority queue, where priority queue comes into the picture in the sense when we go for implementation of graphs in the minimum spanning tree, in those places, like in Prim's algorithm. So in those places we'll be using the concept of priority queue mode, and whenever you are storing some data in that places you can use priority queue based on your requirement. And Dijkstra shortest path algorithm will be using priority queue. Moreover, in Huffman code will be using priority queue in all those places. I can say real-time example application, traffic lights. When you go for traffic signals, so in the traffic signal, based on the traffic, the signal may get varied. So those applications have been designed based on the priority queue. Okay, fine.